Vector purpose. The purpose of this experiment is to practice representing force vector graphically and mathematically, decomposing resolving force vector into components, finding the resultant force vector, adding vector graphically and mathematically. Equipment. Force table experimental setup. Force table simply with the center post and 3 data cable legs, 3 super pulley clamps, 3 mass hangers, plastic ring spool of third. Scalars and vectors. Scalar quantity has only magnitude. A vector quantity has both magnitude and direction. A scalar quantity like length, area, volume, speed, mass, density, pressure, temperature, energy, work, power. And the example of vector quantity is displacement, velocity, acceleration, momentum, force, drag, force, weight, velocity. Theory. There are several ways to find the sum of the two forces and the power of equilibrium. 1. Practically using a force table. 2. Mathematically. 3. Graphically. Hang two different masses of the force table over two pulleys. Adjust the angle between the two strings by moving the pulleys and fix the angle to certain values. Theta 1 equals 0 and theta 2 equal 90. Measure from the positive axis counterclockwise. Hang third masses on the third pulley by trial and error. Change the mass spending on the third pulley and the angle of the third string by moving the pulley until the ring at the middle of the force table is balanced. The force by third masses will balance the force exerted on the ring by the two other masses. Make sure the center of ring is at the center force table. In this arrangement, the ring is said to be equilibrium under the effect of the three forces. Record the value of the masses. Use to calculate magnitude of three forces. Hint, F equal mg. Record the angles the three strings make with the positive axis counterclockwise as shown in the force table. On graphing paper, draw coordinate system. Then draw the three forces using vectors such that the length of each vector is proportional to the magnitude of corresponding force and pointing in same direction. Record your value in the table. Forces, magnitudes, and angles with the positive x-axis counterclockwise. Calculate the component of three vectors and draw them as well on the same plot. Fill the value of their component in the table. Note that the sign of each component should reflect the direction. It is a good exercise to recalculate the component using angles other than the angle with the positive x-axis. Calculate the mathematical sum of the three vectors in vector forms and calculate the magnitude and direction. What is the sum of the vectors? What is they are expecting? Discuss this in the result and discussion part. On separate graphing paper, add the three vectors graphically as explained in the theory part. Measure the length of the net vector, resultant vector, using a ruler and its direction angle. Using protractor, what is the value of the net force? Is it consistent with the mathematical sum? From force table experiment, there is pulley 1 and pulley 2 and pulley 3. Pulley 1 mass is 100, force F1 equal 1, and angle theta 1 degree equals 0. Pulley 2 mass equal 100 and force equal 1 Newton and angle equal 90 degree. Pulley 3 mass is 143 gram and force 1.43 Newton and angle is 2 to 5. Magnitude of resultant force F equal F3 equal 1.43 Newton. Direction of resultant force theta equal theta 3 minus 180 degree equal 225 minus 180 80 equal 45 degree. From component method addition, we are get out S component and Y component. For F component, Fyx equal 1, F2x equal 0, Fx is equal 1. And on the Y component, Fy1 equal 0 and F2 equal Y equal 1 and Fy equal 1. Magnitude of resultant force F equal F2x squared plus Fy squared equal 1 2 squared plus 1 2 squared equal 1.414 Newton. And the direction of resultant force equals theta time minus Fy over x equal time minus 1 over 1 equal 45 degree.